And when the teachers are teaching, take notes simultaneously. That practice you have to have. Okay, you came to college now. The book material will be given, but completely you can't rely on book material. So it is very good. Even the proper book, even if you have also, you have to have the habit of taking notes simultaneously, short notes. Initially, you feel that listening and writing you could not do, but that if you try, no, that will be you will, if you practice, definitely you can do. Okay, but initially you feel you may not, you will not do, because any one only, either you have to write or otherwise you have to listen. But if you practice, definitely you can do. Okay, so that is very important. Okay, our lectures, what lectures we have, that time we don't have any other way, we don't have internet and all. So uh, we had to refer many books, going into library physically, and notes. Making notes was the only source to study that time. Okay, my notes, college notes, still I have. Okay, but anything quickly, if you want to refer, no, you can't go to book. Okay, so you can quickly refer. Okay, suppose you're going for interview, so they may ask a question in any subject. Okay, per semester 5 subject with the practicals you are studying. Okay, so all the subject you can't prepare and go for the interview. Okay, so that time what you can do, you can take your class notes notebook. You can quickly go through it and you can go. So it would be very helpful even after your graduation also. So remember, take it seriously and start to practice taking notes simultaneously when teacher is teaching. Okay, that is very important. Okay. I just share because during last lecture we saw IO management. We saw about IO management. Students, you have to know what is the sequence we are coming. Okay. We saw introduction about the operating system. Introduction on operating system and what are the where actually the operating system located in the system, and then we discuss about two important services of operating system: resource manager and it's an abstract layer for the user. What is the view of the operating system? For hardware, what is the view of the operating system? That we discussed, and after that we saw about the hardware overview. Okay, of the computer, of the general purpose computer. Okay, in that we discuss about the processors, and in the processor we discuss about fetch, decode, execute cycle, and then we discuss about the pipelining and superscalar CPU, and then memory. In that registers, cache, main memory, and then we discuss about the magnetic disk. Okay, and then after magnetic disk we started IO, input output system. In input output system or input output devices we saw device controller. Okay, and then device driver, Actually, IO devices under the IO system or IO devices, device driver will not come as it is as because that is a software. But we should know about the device driver, okay, because that would be the part of the operating system. Device controller, we saw it is a hardware, which is interface between the operating system and hardware. Okay, that we saw. And then we saw input-output device can communicate in three different ways. We are in there only. Okay. What are the three ways the input-output devices can communicate? Or in other way, we can say IO management. Okay. So IO management also imply the same thing. Okay. So IO management or communication between IO devices and processor. By taking three different ways. One is programmed IO, second one is interrupt driven IO, third one is DMA, direct memory access. Okay. During last lecture, we discussed about the programmed IO. Okay. We had to discuss about the interrupt driven IO and DMA. Okay. This three, note down. This three communication between IO and the processor. You don't refer the Tenenbaum book because there they elaborated in a different way by taking the programming also busy wait loop and all. Okay, so that would be difficult for you. And what I am saying, that would be very easy. That material. Only the IO communication, IO and processor communication material I have, I will share with you. Okay. So the thing is, you have to remind to me. Okay. So only these three techniques, the notes I have, I will give you. Okay. Just note down. Then only you will know which material you have to get from me. Okay. Apart from your textbook. Okay. Note down. Okay. Students, not next week, because coming Saturday will be the holiday, 19th Feb. So that we are not going to conduct PTM. Last week, 12th, actually we were planning to conduct, but that day we had this autonomy audit in the department. And then that day itself, we had another alumni talk series also. You did not attend. SY and TY students attended. Okay, so that day we couldn't conduct the PTM, parents teachers meeting. Next, any one of the Saturday we plan to conduct, but this Saturday was also holiday. So 19th also we are not going to conduct. After that, the next coming Saturday to next Saturday. Okay, it will be 21 or 22. So that Saturday you will have PTM. Okay, in the PTM, your classroom interaction, mainly your attendance and your performance in the class test will be discussed. Okay, but now for you, we did not conduct the class test. Of course, before that, actually, I have to post. I will post one quiz. Okay, so if possible, I can discuss about your score of the quiz also with your parents. Okay, individually, the teacher will meet the student. Under every teacher, there are students will be assigned. So that teacher will be responsible to conduct the PTM individually through online. Parent will be called. And then discuss about your performance. Okay. Mainly, we thought we have to convey, we have to say your attendance, because even though sitting at home, you're attending the lecture, what is happening? Your parents are some of the parents are working actually. Some of the parents are busy with the household work. So they may not see you what you're actually doing, and some of the parents they are not knowing about anything in the mobile or laptop what you're doing. They will not understand. So For them, orally, we have to, our responsibility, we have to inform to them about your attendance. Okay. We will go to this. Interrupt driven IO. Okay. This is another way. We saw programmed IO. What was the drawback in programmed IO? Any one of you? Yes. That I can't say because we not yet decided. Any time your lecture, your physical lecture will start. If the lecture started, then definitely your this class test internals will be offline. Okay. Definitely, because now I don't think they will not, even this week or next week, mostly, I think they will start. Okay, within 1 or 2 weeks, not more than that. That I'm sure. Because timing, everything will be informed to you. Because when it is, if suppose your practical and lectures, everything will be offline, then exact whatever timetable now we are following, that we will follow. Okay, there will not be more changes in the timetable. But only if they start practicals, no, then what will happen? Weekly 2 days, all the practicals we have to put. Okay, then other days, the lectures, only lectures will be there. Because now for TY, we are doing that only. TY, we were allowed to do only, allowed to take only the practicals in offline. Okay, so TY's lectures are going in online, practicals are in offline. So that time we have to, because every day we can't call the students for practicals, no. So at the same time, at least 2 days they have to come for practicals. Okay, batch wise actually. So we will take any 2 of the days. Then we have to put all the practicals into those days. For you, I don't think, because now they will open everything as before, lectures, practicals, everything. Because even school started now, standard 1 to 12. When they are going, what happened to you? Many of you are vaccinated also. So definitely you can soon, very quickly, you can expect your offline lectures and practicals. That I'm sure. They won't delay more than this. So now your exams, everything will be offline only. So that I'm saying, you don't think that like last semester, the next semester, last semester you can't consider only it's this. Okay, because practical was not taken properly and the lectures also went online. Your exams also, internals and external are not. It is not actually appropriate. Okay, there are students, those who are really worked hard, scored less, because very truthfully they have given the exam. But those who copied, they scored more. That and all happen. But next this year, this semester, that will not happen. No chance at all. So you make your mind now itself. It is you're going to give the exam offline only. So then you have to prepare accordingly. No, then only objective questions will not come. Objective type question will not come. Descriptive will come. So you have to change the way of studying. Okay. So that and all you have to start now. Okay. Don't think that after they inform whether the exam is going to going to happen in online and offline, we will start studying. Please don't think like that. Yours is 90%. I can say 100 also, but maximum it would be what? In offline only. Even your this internals. Okay. In operating system, the internal presentation will be a case study about the operating system. Okay, I may give some topics, for example, scheduling. How the scheduling will be in Unix operating system, in Android operating system. Some topic on some operating system will be given. You have to collect the information and then you have to make PPT and you have to present. Okay. So that would be the presentation. I think if lecture started, no, if the lecture starts, then that presentation also you may need to give in offline. That we will see. Okay, once if started, everything started in offline, then no doubt everything is going to be offline only. Okay, students. Next communication pattern between the IO devices and processor is called the interrupt driven IO. What was the drawback in the programmed IO? Any one of you? Students, am I audible? Because I did not wear any earphone, headphone and all. Clearly audible. Okay. So, yes. Drawback of programmed IO.
Ma'am, it will take maximum time for IO operation. So it will degrade the speed of processor.
Yes. Here you have to mention very importantly this one, polling. That term you have to specify because processor will spend maximum time on IO polling. IO polling means what? Without doing any IO, without doing any other operation, it will only look at the CMD, command register. Okay, whether if the register is set to the IO operation, got over. So it will keep on go and poll the IO device. Poll the IO device. It is not like IO device will complete the operation and then after completing it will inform to the CPU. No. It is CPU's responsibility, the initiating the communication and also keep on polling to ensure the IO communication got over or not. Okay. So that is a big disadvantage. Polling, CPU polling is a very big disadvantage because that as Sweetie, know your name. Sweetie said it will degrade the performance of the microprocessor. Okay. So that is a disadvantage. So to overcome this, we have another this communication interrupt driven IO. Look at the picture. I have drawn just roughly. Okay. So this side, if you see all the IO devices, I will say this. This is IO request. This is IO acknowledgement. Okay. So IO request. Here all the IO devices will be there will be more than one number of devices connected. Okay. And suppose assume that there are more than one number of IO request comes. Okay. Here you may wonder how more than one IO request. Here we are assuming the system is completely multi-processing system. That means more than one process is getting executed simultaneously on the system. You know, no, you could imagine, no, a multi-processing system. You are starting your computer or laptop. You are listening the song. You are editing the video. Okay. You are just reading the mail. Okay. There are more applications at a time you opened. Okay. In this, more than one number of application may need input or output operation. Okay. That means more than one number of device could be connected with our keyboard. You have to give input to your mail server and also your song. You have to choose a song which should be played next. And you are simultaneously saving some document also. Word may you are typing and saving. So all these are what required required communication with the other devices. Okay. So that you can imagine here. So when more than one number of IO request comes, input or output request comes, there is a, you can imagine this as a interface, IO interface. Okay. In the previous scenario, in programmed IO, you remember IO interface has address decoder and then many registers, in register, out register, signal register, command register, all those were there. Okay. Here it is different. There are other components in interrupt driven IO. Priority encoder we have. What the priority encoder will do, though when more than one number of IO request comes, it will choose any one of the IO request. That IO request, how it will choose when it is coming, when more than one number of IO request comes, how this priority encoder will choose only one IO request, that is based on some algorithm, priority. Okay. Now, how the priority would be, sometimes FIFO priority, for example, among these IO requests, which IO request hit the priority encoder first, which came first, we can say. Okay. That could be the algorithm, or which one is the shortest, very shortest time it wants to execute use the processor. Okay. So that could be the algorithm of the priority encoder or any other algorithm. Okay, a round robin algorithm, any algorithm. Okay, you did not study the FIFO or shortest time first and all, no? Okay. Students, the priority encoder will choose the request based on algorithm 1, which request came first. Okay, that is first come, first served. Which came first, that will get served first, serviced first. Okay, that could be one algorithm. Another algorithm could be shortest job first. Assume that here there are 10 requests. Okay, in that one particular request wants to use the processor very less time. Okay, the time is called CPU burst time. The time period, the input output device wants to use the processor is called CPU burst time. Burst, B-U-R-S-T, burst. Okay. So that CPU burst time, based on the lowest CPU burst time, also the priority encoder can choose the request. Okay, first FIFO algorithm. Second, very shortest job first, shortest CPU burst time algorithm. Or there are many more algorithms. Okay. So in that, by following any one of the algorithm, the priority encoder will choose any one of the IO request. Okay. Upon choosing the IO request, the priority encoder will give that what we can say, priority number of selected request to the comparator. Okay. The comparator is another hardware, okay, device. That comparator will compare the priority. Two priorities it will compare. One is the priority number of the request, what the priority encoder selected now. Suppose assume that the priority encoder selected I request 1. Okay, this IO request it has chosen based on some algorithm. So each and every request will have a priority number. Okay, that will be added by the operating system. That we will see later. Now just ignore that. So each and every one will have its own priority number. So that priority number, it will, with this priority number, will be compared with some currently ongoing process priority number. For example, now currently one particular process is getting executed by the processor. Okay. So what is the priority of that currently being executed process priority number? That will be, so that's why one input from here, one input from here. Okay. So the priority number of the request which is selected by the priority encoder and currently ongoing process priority number, both will be compared by the comparator. Okay. Suppose the newly came this process, no? That means the request selected by the priority encoder has highest priority than ongoing process. Then what will happen? The operating system will stop the processor, and it will evict means it will take out. Okay, it will evict the ongoing process, and that this process will be kept inside the ready queue. And then now this new process, no, which came from here, which has very highest priority, that will be inputted here in the processor by the operating system. So now our processor will start to execute that process, and then upon completing that process, that will be go to any other state, waiting state or something, and then the process which was executed just before, no, that will be taken by the processor, and it will start the execution. Okay. So after completing all this will happen once after the CPU placed the IO request. Okay. Now after the IO system, after completing all this, then it will interrupt. Now it completed one particular process, no, operation of one particular process, which is selected by the priority encoder. Now the entire this IO system will interrupt the processor. Assume that this side processor is there. It will interrupt the processor to say that yes, I completed the work what you have given. Okay. So look at the scenario here. What is happening? Like the previous scenario here, CPU only giving the work to the IO system. But after completing that IO task, IO system will interrupt the CPU to say that, to inform that I have completed the operation. The previous case, it is CPU's responsibility, processor's responsibility to see that whether the IO operation completed or not. But now upon completing the IO operation, the IO subsystem will inform to the CPU, yes, I have completed the work. Okay. This is called the interrupt driven. Why interrupt driven? Because the IO system will complete the work and then it will interrupt the processor. Interrupt the processor. By the time what the processor will do, processor just assign the work to this and then it will go and do other work, other assigned work. It will not keep on poll the CMD register. Okay. So in this model, we just little more uplift the performance of the processor. We increase the performance of the processor considerably, not to some extent. Okay. Why I am saying to some extent? What will happen? Suppose 4 blocks of data. 4 blocks of data should be transferred to the printer. Okay. What will happen? Suppose assume that this processor is a 8-bit processor. Nowadays, no 8-bit processor. Just for simplicity, I'm saying 8-bit processor. 8-bit processor may at a time 8-bit only. For example, assume that there are 3 blocks of data. I said no. One block has 10 bytes. Okay. So first 1 byte, because the processor is 8-bit processor. So 1 byte equal to 8 bits. So only 1 byte will be transferred at a time. So after transferring 1 byte, the IO system will interrupt the CPU. Again, it will transfer another byte. It will say that yes, I transfer the second. Third byte, like that, it will interrupt many times. But when comparing with the programmed IO, CPU will get some time to work on some other operations. Okay. That is the interrupt driven IO. Now here, why all these arrow and all? As I said here, IO request comes. IO request. How itna IO request is coming? Here, I assume that there will be a processor. Okay. So processor is connected with many IO, input output devices. So there are simultaneously the number of programs is getting executed. Of course, more than one number of input output statement the processor would come across. Okay, so all these will be inputted to priority encoder. Priority encoder will choose any one of the request based on some algorithm, and it will input that to comparator. Comparator will take the priority of the ongoing process from the processor, and also the process which is selected by the processor request, okay, selected by the priority encoder. Both the priority will be compared. Okay, if only, please understand, if only this priority is higher, priority encoder selected process priority is higher, only the comparator will react. That means comparator will give the output. Otherwise, the comparator will not, because there is no context switching is required there. Suppose here this process is having higher priority. What should be done? This process, ongoing process, should be evicted, and this process, newly selected process, should go to processor. Okay. Suppose vice versa. Suppose ongoing process priority is higher than the newly arrived process. Then what will happen? No change, because the ongoing process will continue the processing, it will complete the processing, and then it will come out. Then this will go. Okay, there is no problem there. Okay, when the problem arises, when the newly selected process has high priority than ongoing process, then this process will be stopped, and in the halfway it should be evicted. It will be executed later after completing the newly selected higher priority process. So if suppose this newly selected process has high priority, then only the comparator will give output. What will be the output? The priority number, current priority number in the register should be changed, because now currently chosen this new process. So uska priority number would be very different. So that should be stored in the register. That is one thing. Another one, the comparator output will go to the decoder. The decoder will decode the address and find which particular IO device has selected. Because upon placing the request, all the IO devices will expect what will be, which IO device has selected for the communication. They are waiting now. Okay. How they will get acknowledgement like this? Decoder will send the acknowledgement to the corresponding IO request, saying that this is the IO request selected by the priority encoder. Okay, this is clear. So the IO operation will happen like this, and then it will be interrupted. The IO device will interrupt the processor just to confirm it has completed the IO operation. Okay. Do you want to ask anything here? Should I repeat anything? Okay. Next, DMA. DMA I will show in the PPT. This is a diagram for DMA. I will share this PPT with you. Okay. So DMA is a third way of communication. Okay, direct memory access. Okay, direct memory access. Here what will happen, the CPU, here actually the hardware architecture will differ, because hardware there will be one extra peripheral that is called DMA controller, direct memory access controller. Okay, so it will be little expensive, but it will it will work in very good way. That means it will increase the performance of the processor in considerable amount. It will increase the processing speed of the processor. Okay. So here there is a CPU, our usual CPU. The CPU will, this is a first step. Just by seeing this diagram itself, you can write the theory. See, this is a step 1. Okay. And this is step 2. This is 3. Okay, this is 4. This is 5. So these are 5 steps in this communication. Okay. What CPU will do? CPU will program the DMA controller. Suppose the CPU is receiving any IO operation, input or output, read or write operation. Immediately what CPU will do, it will load some data in a DMA controller. For example, address. DMA controller will have all these registers. Look at here. So address. Inside the address, CPU will load the address of the device in which the DMA controller should communicate. That means the read operation should be performed with which input device, or write operation should be done with which output device. So that address of the device will be address of the device, IO device, and also address of the location. Address of the location inside the IO device. Why address of the location? Matlab what? See, suppose the operation is a read operation. Okay. During the read operation, what will happen? CPU will send the address of the device. That means CPU wants to read some data from the input device. Okay. So from where to where data should go during the read operation? From actually CPU should give the details. It will not give the data. Okay. Data will be there in an input device. From the input device, the data should go to CPU during the read operation. Please listen. During the read operation, data will go from the input device to processor. Okay. During the write operation, data will go from the processor to output device. Processor to output device. Imagine printer. Okay. Printer clear data will go from the processor to printer. Okay. Printer will not give any data to processor. Okay. Processor should send the data to printer. Printer is the output device. Okay. That's a write operation. Processor will write the data on the printer, which should be printed. Okay. But if you take keyboard should give the data to the processor. Processor will not give any data to what? In the keyboard. Okay, to the keyboard. So the operation is like that. So if it is a input operation, what will happen? CPU input, that means read operation, what will happen? CPU will place the address of the input device and address of the location from where the data should be read in the input device. Okay, all will be placed in the address register. Count. This count will be set to some particular, for example, assume that this transaction, the CPU will know the transaction cycle. For example, this particular transaction which the CPU is currently placing to DMA, that will take 10 cycles, clock cycles, assume. Okay, that is the time, okay, taken to complete the input or output operation. So 10 will be placed here. Okay, that's a count. Within which time the process should be completed. Control register may the operation, read operation or write operation, that what signal, input or output signal will be loaded. Getting it? Address register. Inside the address register of the DMA controller, address of the device and the location from where the data should be read will be stored during the read operation. And then count may within how much time the read operation should be completed. This is clock cycles. Okay. And then in control signal, which one read operation should be performed or write operation should be performed, which operation that will be loaded by the processor to the DMA. That's all. All the information, whatever is needed to perform the input-output operation, the CPU placed inside the DMA. That's it. Placing all these data, CPU will go for other work. Now the DMA controller is going to act as a CPU. Okay. So what will happen? The DMA controller in the second step, it will send the DMA request to the memory. That means it will say to the, this is actually your entire device. The device will have, I said, controller, no? Controller, and then this is the actual device. Okay, the device could be anything. Here it is memory device. Okay. So the control, I said the controller will have small buffer, that is this. Okay. So DMA will say that this is the so and so address. So that is this particular device address. From there you have to read some data and give it to me. That should be completed within 10 clock cycles, and the operation is read operation. Okay. So now what the disk controller will do, disk controller, this buffer is a small buffer. This buffer size is completely depending on the word size. As I said, suppose the processor is a 8-bit processor, the buffer size is 8-bit. Okay, so it's a small buffer, memory. Buffer is a memory which will load the temporary data. Permanent data cannot be stored in buffer. Okay, only temporary data will be stored in this memory. This memory is a device memory. That means inside the controller it will be there. So it's called a device memory. So inside the memory, from the device, it will take the data. How it will take the data? 8 bits it will take. Because this, after taking only 8 bits, this will be filled because the buffer is very small, 8-bit buffer. Okay. And then that 8-bit should be stored to send to the memory. Again from the device, again 8-bit. That will be stored in the memory. Again 8-bit. Because the register is small, our processor is also, word length of the processor also 8-bit. So like that, all the data, whichever the CPU wants to read from the drive, that will be after transferred all the data to memory. What will happen? This device controller will give the acknowledgement to the DMA, because DMA gave work to controller. No, controller now transferred all the data. Now the device controller will give the acknowledgement to the DMA. DMA controller will give interrupt to the CPU. Now here also interrupt is happening, but this interrupt is completely different from the previous one. Previous one, that means the interrupt driven IO, what will happen? It will send one byte and then it will interrupt. When send another byte, it will interrupt. Okay. But here it completely complete the transfer of the data. Okay. And then it is interrupting the CPU. Now what the CPU will do, CPU will directly read, because CPU is only having authority to directly access the memory. So it will just take the complete data through the bus. This is a common bus connected with all the device. In this bus, it will take all the data. CPU will take all the data and it will proceed the processing. Okay. So like this, the DMA controller is here in this communication scenario. It will act as a processor. Okay. So what will happen? The processor can do other work. It no need to be idle at all. Its only work is whenever IO operation comes, it has to just give the proper details to DMA controller. By taking all these details, DMA controller will completely complete the input or output operation, and then it will interrupt. Interrupt means it has to inform, no, the work got completed. Then the CPU will look into the memory and take the data. Okay. Okay, so this is the DMA. So we saw 3 types of communication between the processor and the IO operation. Okay. Okay, this you have to go through and come. Okay. Thank you, students. You all can leave now.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am. Bye, ma'am.
Ma'am.
Okay, bye, students. Bye.